right. So we're going to move on to actually using the binomial theorem, but before we do that, we need a quick video that talks about a math symbol or a little bit of notation you're not familiar with. So the symbol that we're going to learn in this particular video is we're going to learn how to do what we call n choose r. So there's two ways to write n choose r. You can either write it as a little subscript n, big C, subscript r, so n choose r, okay? Or you can write it as an n on top of an r in parentheses, okay? So both of these, if you read them out loud, you would read them as n choose r. All right, and I'm going to walk you through what this notation, both of these are exactly the same thing, different notations for the same thing. So for instance, today is the 8th of May, right? So I could write today as 5/8/2020, or I could write it as May 5th, 2020, right? I could write it out as in words, or I could write it if I were in a different country, I would write it as day first and then month and then year, right? So they're the same thing, just a different way to write them. So these mean the same thing, and what both of them mean, okay, what they mathematically actually mean. So this is the notation, and this is how you read it. What they mean, so what NCR or n over r in parentheses, which we read as n choose r in either case, what this actually means is n factorial over n minus r quantity factorial, r factorial, right? And essentially, so this is going to matter in our binomial theorem, right? But this is the way that you can choose. You have n items, and you can choose r of them if order doesn't matter. So if, for instance, there are 20 kids sitting in my class, and Mr. Domers calls and asked me to pick 5 of them, then there would be 20 choose 5 ways to pick you as long as order didn't matter. It's a different story if he says the person that you pick first is going to get a $20 prize and the person you pick second is going to get a $15 prize and so on. That's a different situation. But if it doesn't matter what order I pick the 5 people, the way we would find the number of possibilities would be to do 20 choose 5, right? Because out of 20 people, I choose 5. So that's why we say n choose r. All right, so let's walk through an example using n choose r. We're going to evaluate a couple of these just to make sure you get the concept of how it works. So this is our example 3, right? So we're going to go ahead and evaluate a few of these, and I'm going to show you how to evaluate them in a calculator too, although for smaller numbers, they're not awful to do by hand. So in A, we're going to do 3 choose 2. We're going to do 5 choose 3, sure. We'll do 10 and pick, we'll choose 7, so 10 choose 7. And we'll do, I don't know, let's do 100 choose 99, because that'll prove a point. Okay, so, cool. Sorry, the dog is very close to rolling into the video. Okay, cool. Stay, Bailey. All right. So let's walk through this. So let's use the formula for 3 choose 2, right? So this formula would be 3 factorial on top of 3 minus 2 quantity factorial, which would be a 1 factorial, right, times a 2 factorial. So that's going to end up being 3 times 2 times 1 over a 2 times 1, so it just ends up being a 3. Now, there's a really logical way that this comes out as 3, and I'll just walk you through it. We will talk about this more later when we do other sections in this chapter. If I have 3 items and I'm picking 2 of them, there's exactly 3 ways to do that, because if I'm picking 2, that means I'm not picking 1 of them, right? So if, for example, I'm holding a red ball and a blue ball and a yellow ball, and I'm picking any 2 of them, I could either choose not to pick the red ball, that's one way I could do it, I could choose not to pick the blue ball, that's another way, or I could choose not to pick the yellow ball, and those are the only 3 ways I could do it. So it's not a surprise that it comes out as 3, because it's 3 choose 2 of the items. So if I do 5 choose 3, right, this would be a 5 factorial on top of a 5 minus 3 factorial, which would be 2 factorial, times a 3 factorial. So if I clean this up a little bit, right, this is 5 times 4 times, what I'm going to do is just leave that as 5 times 4 times 3 factorial, because I can cancel the biggest factorial on the bottom with that, and I'm going to get that there are 20 divided by 2, or 10 ways to do this. So if you gave me 5 items and I were going to choose 3 of them with no regard for order, I could do it in 10 different ways. Let's go over here and do 10 choose 7, right? That would be 10 factorial over 3 factorial times 7 factorial. Again, the same trick applies. I'm only going to write the 10 factorial out until I get to 7. So 10, 9, 8, and then 7 factorial, because what's going to happen is the 7 factorial on the bottom, which is the larger of the 2 factorials, is totally going to cancel. So I'm going to get that this is essentially a 10 times a 9 times an 8 divided by a 3 times a 2 times a 1. So I'm just going to cancel some stuff out of here. I'm going to cancel a 3 out of the 9 and make it a 3. I'm going to cancel a 2 out of the 8 and make it a 4. So I seem to get 12 times 10 on top, which means that there are 120 ways. So if you had 10 items and I asked you to pick 7 of them, you could do it in 120 ways if order didn't matter. So 10 choose 7 is a 120. Now, the 100 choose the 99 is the same basic problem I gave you when I did the 3 choose the 2. Although it looks really daunting, it's going to be the same situation. If you think about it, if I have 100 items and I'm choosing 99 of them, then I'm choosing all but one item. So there are exactly 100 ways I could do it because I would leave one item out in each possible scenario. So 100 factorial over 100 minus 99 is a 1 factorial times a 99 factorial. If I wrote this out, it would be a 100 times a 99 factorial over a 1 times a 99 factorial. The factorials cancel, and I get that there are exactly 100 ways to do this. So that's how n choose r, or essentially we call these things combinations, but that's how n choose r works.